Ready to find your flow? AFSA's got you covered.
That's right. The hands-on training lab in Richardson, Texas is where you trade PowerPoints for pipe wrenches. Real tools, real systems, and real experience you can actually use.
And if you're ready to test your skills, check out the hands-on NFPA 25 workshops, where you'll inspect, test, and maintain live sprinkler systems and fire pumps. No simulations, no fluff, just pressure, flow, and know-how.
It's the perfect way to get under pressure without cracking under it.
So get fired up and register today at firesprinkler.org. Spots fill faster than a charged branch line.
AFSA, where you don't just learn the code, you live it. Welcome to the K Factor podcast, where we turn up the heat on all things fire protection. Brought to you by the American Fire Sprinkler Association, this podcast sparks conversations about the latest technology, trends, and tools shaping the industry. Join the AFSA tech team as we fan the flames of innovation in fire safety.
Welcome to another episode of the K Factor podcast. We're here with Hose Monster Company. We have Michael Anderson, Director of Operations, and Patrick Spillane, Global Portfolio Leader. Thank you so much for being here.
Thanks for having us.
So we're in for Hose Monster University. We appreciate you us hosting it down here.
Absolutely.
So what does that look like, and what are y'all doing down here?
Yeah, so we had a 2-day training class on everything flow testing for water-based fire protection systems. So we focus in on fire pump testing, fire hydrant testing, standpipe testing, as well as forward flow testing and backflow preventers.
Awesome. So flow testing, all of the flow testing.
Right. all cover it all, right?
So in my experience, flow testing seems to be a kind of a hard thing for people.
Yeah, I would agree. It's definitely one of those pieces of knowledge I think that's missing from you can get a 20-year-old fitter who knows everything about sprinklers and has been doing testing for a long time, but I think flow testing is still that portion that there's a lot of education that's still needed for in the industry. So
what's
and then with water damage being our one of our biggest, I guess, claims against us, right? And okay, we're going to go actively start flowing water, right? Then it's the whole other consideration of, okay, how do we do this? How do we do it safely? Where's the water going to go? What does that look like? So there's a whole extra level of kind of planning and preparedness.
Absolutely.
Right?
Yeah.
So,
I mean, if you think about how devastating water can be, how powerful water is, right? We really have to respect it and go into any job that we're going to be flowing water with a lot of preparation and thought before we just start opening valves, right? And just flowing a bunch of water somewhere. So
how did you both get involved in your background with flow testing equipment?
Well, I was a lifetimer in the fire protection world. So born into a contracting family in Chicago, worked there for a very long time. The joke that I give to everybody is that my birth certificate actually has fire extinguisher on it, because that was my father's profession when I was born. But got involved, with the Hose Monster Company 14 years ago in a sales capacity. I was a user of the equipment back as far back into the early 2000s, and so big proponent of it. So it's where we sit today.
Yeah, and I'm kind of a similar background as well, too. So I grew up in a firefighting family. My grandpa was a firefighter for the city of Chicago for 27 years. My brother became a firefighter as well, and I became a firefighter in his footsteps. So I was a full-time firefighter and paramedic in the suburbs of Chicago. And then my days off, like a lot of firefighters, you work 24 hours on, 48 hours off. And so my side job was end up getting a job at a sprinkler company.
Awesome.
So got in just doing sprinkler inspections and learned the trade. And after quite a few years working there, I ended up starting up my own shop and eventually became a full installer engineering company and ran that for about 15 years. Throughout that whole time, really I focused in on ITM. Fire pump testing was really my niche. And then after about 15 years, I ended up selling that company off and started looking around to see what my next adventure was. And I saw the Hose Monster Company was looking for someone like me, and being a Hose Monster customer for over 20 years, it was a great fit. So
easy. I mean, they didn't have to sell you much if you're using it a lot, right?
Right. Yeah, exactly. For sure.
So I guess both from Chicago, what's the go-to food place in Chicago?
Portillo's has got to be the top of the list.
Portillo's,
Yeah.
Deep dish pizza, Gino's, Uno Pizzeria. Lots of places.
A lot of good food.
A lot of good food.
A lot of good pizza, a lot of good beef.
What do you think is the tie-up with water flow testing with the users?
I think a lot of it's probably just overall understanding of what they're looking to achieve. We're there to either evaluate a system, right? Evaluate that fire pump, to do a performance test on it to see how it's performing compared to the manufacturer's settings, or it's understanding the test that they're looking to achieve, right? What results are we looking for and why? What's the purpose of it? And I think when you break it down, it makes things a lot clearer and easier to understand, whether it's hydrant testing, pump testing, standpipe testing even, right? I think a lot of people, they overthink and they put too much thought and make it a lot more complicated than it really needs to be. So.
Well, and then on the flip side, there's the whole scary aspect of the fire pump. Walking into the fire pump room is scary enough because it's something that a lot of people aren't dealing with day in and day out. You come in for maybe that annual fire pump test if you're not doing the weekly churns or the monthly churns, right? And so there's a little bit of intimidation factor there. And then at least when you're pretty fresh in the industry, you're stuck outside. Okay, give me these pressures, and you go, okay. And then there's a whole bunch of data on the other side. So I think the other part of it is, what do we do with that information, right? The whole analysis part of it, and then how we make the decisions on are we in good shape, or are we not, based off of the information we're gathering. But I think there's probably also a little bit of the intimidation factor on, okay, I've got all these numbers. What does that actually mean for me?
Yeah. And you're right. That's a huge hurdle to overcome in the industry, and there's a lot of testing software out there now. So we released our fire pump testing software last year in October. And the great thing about it is it's not only does it take the data, right? Any fire pump testing software, you put the data in, data out, right? It just prints it out. What our software does is we take that data for you and we analyze it and we compare it to the manufacturer's setting of that fire pump. So we can let that inspector know, yes, the fire pump, it was able to achieve the 100% of its flow rate. It was able to meet the system demand of the placards that you entered into the system. So we're taking that data and we're helping analyze it. So we're instructing that inspector not only they can understand the test a little bit better, but now they have a little bit more of direction to, hey, how do I move forward, right? Do I need to repair something? How do I explain it to my customer? They have more data and more knowledge then to be able to pass along. Right. So, but you're right, that fire pump room, it's an intimidating room to walk into, but it's also one of the most dangerous rooms in our job to walk into, right? I mean, a lot of high voltage equipment. When things go wrong, a lot of times it happens in that pump room, right? That's usually where a coupling lets loose that wasn't grooved properly, or something goes wrong, and there can be a lot of water damage. And when you mess water with high voltage, 480 volt electricity, right? You're looking for a recipe for a disaster if you don't know what you're doing. So
well, and it doesn't even necessarily have to happen in the room, right? So you kick the pump on, and all of a sudden something on the other side of the plant goes wrong. You're not aware of it until somebody comes yelling a couple minutes later. Oh my God, turn it off!
Is that a pointed story you are willing to share?
Oh
no, I'm just
no.
I guess sometimes we get questions too. If there's so many different orifice sizes, why would there be variability in the orifice sizes? And
accuracy.
Okay,
and it's a point to accuracy, is that to meet the current standards, whether it's NFPA or being FM approved or UL listed, is that to hone into that accuracy piece, you need to have very specific orifice sizes, because beyond trying to measure a larger amount of water with a smaller orifice then becomes less accurate. So you kind of tune everything into that point, whether it's an inch orifice device upwards of our big boy pedalless nozzle is 3.05 inches, and even our legacy steel stuff is with orifice plates are pushing 4 inches. So it is critical to have multiple orifice devices in order to get as accurate of a test as you could get done.
To tie it back to NFPA 25's, that 5% pressure, right, is kind of what we look for, which is 5% of 50 pounds, 2.5 PSI. So we should be accurate on our testing, right?
Yep.
And it's funny because if you look at the history of flow testing and how we got here, that first 120 years of flow testing was inaccurate. Really, it is the only fair way to say it. We were using a handheld pitot tube. Still used today. Probably our biggest competitor out in the field is still the handheld pitot tube, But the problem is people use it wrong. I mean, there's no other easy way to say it, but they were taught wrong. And it's that telephone game of training that's happened. It happened to me when I was a firefighter. They taught me how to use a handheld pitot. Just go in there and stick it right up against the nozzle button. Just get it center and you got your pressure reading, right? And that's what most people think. I just need that pitot tube dead center. But they forget about the next important piece of information. It needs to be half the distance away based off of the nozzle size that you're flowing through. And that's the hard part, right? Because how do I get exactly, if I'm flowing through an 1 3/4 pedalless nozzle, I have to be 15/16 of an inch away exactly dead center to get an accurate measurement with a handheld pitot tube.
After drinking 2 monsters.
Right, exactly, right? And holding it in all that strong
fighting
force.
the water and the gauge is
Right?
bouncing and you're sitting there trying to, okay, am I far enough away, but also what's my reading? And there's water on the gauge. I mean,
it's all over the place. So so it, to be accurate, it was riddled with inaccuracies for years, and until Hose Monster came along in the mid '90s. Phil Barrett, one of the original founders of Hose Monster, he was a fire sprinkler contractor down in Kansas City, and he saw how inaccurate this was, and not only how inaccurate, but how dangerous it was, though, too, using play pipes and handheld pedalless nozzles. People would build their own flow test trailers and flow devices, but something goes wrong, right? That's 40, 50 pounds of brass swinging around at a high volume rate. It could be a pretty dangerous situation as well, too. So.
Absolutely, yeah, and flow testing was created back in the 1700s, right? The very first pitot tabletop device was created, and it's advanced now to the equipment today, right? And that's been based on orifice sizes and safety. At the end of the day, we took what was dangerous with a handheld pitot and inaccurate, and took that out of the hand of the pump tester, and we were the first ones to devise a device that had a built-in pitot, standardize the measure point. Didn't have the human inaccuracies to it, and we were able then to take that to UL and subsequently FM to get approvals because we could provide repeatability with the device, right? And so that changed the pump test world. Again, as jokingly speaking, we didn't invent flow testing, but we perfected it.
We've come a long way since the pitot tube, though, too, right? Our first steel Hose Monster, it had that built-in pitot tube. But one of the challenges with that as a sprinkler contractor, fire pump contractor, right? You're doing a test, and a rock, piece of debris, some junk comes flying out. Next thing you know, that pitot tube gets damaged, it gets clogged, and I got to shut down my test and change out my pitot tube in the middle of a test to continue. Fred Grenning, one of our original founders that teamed up with Phil Barrett, he saw this and saw the challenges, and that's when he came up with the pedalless nozzle technology. So now we can measure water flow very accurately, but without a pitot tube. And we've moved far beyond that old school pitot tube technology. That pitot tube, we should almost, I think it's ready to be sunsetted out in the day, because now it's pedalless nozzle. That's where we get our most accurate measure and our most consistent reading every time, because we create a nice laminar solid flow with our pedalless nozzle technology.
So I think there's probably a lot of listeners who might not know exactly how a pedalless nozzle works, right? I get the idea of the pitot, right? Because I can envision that. I know how it's at least conceptually working with the velocity flow. Can you explain a little bit about how the pedalless nozzle gets me the same?
Yeah, so the pedalless nozzle has a unique curvature on the inside of the nozzle that creates a laminar or a solid flow of water, which scientifically is very easy and very accurate to measure by the K-factor formula, by putting a gauge port in a specific spot on the nozzle. So we're actually reading an internal flow pressure versus a pitot device, handheld or other, where it's reading an external jet pressure to it, which is a turbulent discharge. And so you'll see in those devices that where a needle bounce is quite prominent. And so you're essentially guessing between 25 and 32. What's the middle point to that, right? Pedalless nozzles, you put a gauge on those, and the needle remains steady. So it adds to further accuracies. You're not guessing.
Another question that seems to come up as well, because a lot of the flow comes from the good old 29.84 times our coefficient of roughness times the diameter squared, and square root of the pitot pressure. Yeah. And that coefficient of roughness typically is less than 1. And I think sometimes we see it's higher than 1.
Yes, with the pedalless nozzle.
How does that work?
Well, it's a common question we get all the time, especially more from engineers, right? That see that, hey, how can we be greater than 1.0 as a coefficient? And the simple answer is it's not. That coefficient that we're talking about, that's related to what Michael said, the jet pressure. When we're measuring that jet pressure externally with a pitot tube, we're taking an internal nozzle pressure. So we're designed based off the same way a sprinkler head is designed, a K-factor. So if we know that internal nozzle pressure, and we know our K-factor, then now we know how much water we're flowing. So we're designed based off of the K-factor. Our flow rate is K-factor times the square root of pressure, right?
It's a podcast shout out.
There you go.
And so to be able to use that, though, so a lot of software out there, though, right? They use the John Freeman Q formula, 29.84 times coefficient times the diameter squared times square root of pressure. So to be able to plug into that, we had to figure out a way, okay, how can we use our technology, but it still can be used with that formula. So we were able to reverse engineer to figure out what would our coefficient be if we were using it in that same formula. Again, but because we're dealing with a lower pressure, our internal nozzle pressure is going to be a lower pressure than that jet pressure that's discharged. If you look at Antonio Venturi, the Italian physicist who really studied water flow, who kind of studied the whole industry of how water can be measured accurately, he saw that as water is constricted and it reduces in size, it speeds up. Right. It increases. It takes that energy that's pushing out against the external nozzle side of the pressure, and it's changing the direction of that force, and it's creating a more of a faster velocity check. Right. So it's like putting your thumb over the garden hose. Right. When you put your thumb over that, you squeeze the water through, and that water speeds up and comes out as a jet pressure. Right. So as that jet pressure increases, though, the nozzle pressure decreases. And so by able to look at that, that's what really came out to be able to us to determine a very accurate flow rate. So.
That also, I guess it also makes sense because when you start looking at that equation, a lot of times it has to do with turbulence. And we're talking about right angle turbulence, or if it's protruding, and if it's smoothing that flow, making it more laminar, then it makes more sense that it's above 1 for those who are listening.
Well, if you look at, if we put a pitot tube on our pitot-less nozzle and we took that measurement, let's say when we're flowing 21 psi internal nozzle pressure, which is 503 gallons a minute.
You haven't looked at those charts at all.
But if I took a pitot tube and measured what's discharged out of that, I might have 23 psi internal nozzle, but my discharge pressure is going to be about 27, 28. So by making a higher coefficient, that's where the higher coefficiency comes in. We're making up for that nozzle pressure difference, as well as all the everything. If you summarize what a K factor is, right? K factor is technically that 29.84 times the coefficient times the diameter squared, right? All that's built into that K factor. So essentially, it's really the same formula. Now we're just plugging and playing which pressure is being what, and we're summarizing all that information into a K factor.
And I know there's a lot of people out there that are thanking you for those charts too, because that equation for some people, especially in the truck, can be a bear.
Yep. Yeah.
Where do you see the future of water flow testing going?
Well, it goes to technology, right? You know, the industry as a whole has created, you know, a number of flow test devices that comply with certain standards, but the standards are so tight at this point to create more accurate devices becomes almost impossible to do. We're using minimum gauge, accuracies of 1%. So the devices are 2%. You know, what are you going to gain from that additional 1% of accuracy? We've taken the approach here at Hose Monster where we've invested heavily into technology. So we were the first to bring technology to flow testing, both in terms of operating and reporting softwares. And now with the introduction of the Smart Monster line of equipment really will be game changers for the industry. And whereas we all live on and in our phones today, we'll also do in our private lives, we're also going to be doing that in our professional lives. And Patrick can talk about Smart Monster.
Yeah, because what we've done with Smart Monster is it's a digital Bluetooth gauge. It replaces any analog gauge. So whether we're using it on the fire pump, on our suction and discharge gauges, or on all of our flow devices, can be used on any Hose Monster equipment. Even if you still have a 1996 steel Hose Monster with the built-in pitot, you can attach it to that, or you can be on your brand new pitot-less nozzle. What it does, though, is it opens and works automatically with any iOS, Android device. You just download the app. You don't have to pair the devices. It's automatically going to pick up those signals. And then now your phone becomes not only the face of the gauge, but it also becomes your flow chart, because you go in there and you say, hey, I'm using an 1 3/4 pitot-less nozzle, open atmosphere. So now it's going to take those live pressure readings. It's going to convert and calculate the flow rates automatically. And now I'm getting a nice digital accurate reading. And one of the great things about those, if you look at our flow charts, right, we're jumping from 1 PSI increments, 10 PSI to 11 PSI. We might jump up 30, 40 gallons by doing that 1 PSI jump. Now with with Smart Monster, we can read down to 10,000ths of a decimal point. We round it down to just 1/10 of a decimal, 1/100th of a decimal point. But now we can get very accurate flow rates. So now we can get all those numbers in between on our flow chart. So we know exactly where we're at. So what it helps us out to is when we're dialing into our flow rates, I'm not really concerned about each individual flow line. Now I can open all lines at one time, control it with my OS and Y valve on the inside. And now I can feather it in. I can get pretty much dead on to exactly whatever I'm looking for, 1,000 gallons a minute, 1,500 gallons a minute. So that was our first step with Smart Monster. That's where we're at today. Our next steps, though, is bringing pump testing into a very accurate measurement. And it's beyond just flow at that point, though, right? Because if you think about what we're supposed to be doing, we're supposed to be doing a snapshot in time of that fire pump. While flowing this amount of water, we need to have our discharge pressure, our suction pressure, and our RPMs, and technically our amps and volts. And it's not required by NFPA anymore, but it's nice to have if we can have that data, right? We want to capture that all at in an instant, right? But technically, we don't do that. When we do a fire pump test, we're doing it over a minute and a half, 2 minutes, right? So is it really a snapshot in time at this point? No, right? Because a lot of things can change. As soon as you look at your flow rates, you go and you're writing down your suction and your discharge, and you're getting your tack out and you're taking your meters. And next thing you know, the guy's not telling you outside that the valve's walking on you, and now your flow rates have changed. So what we're doing and where we're moving with Smart Monster is we want to be able to get an instant snapshot of everything all at once. So we have our new Bluetooth technology coming out with our RPM Connect. So now we're going to be able to get our RPMs digitally Bluetooth into the same device. And so now we can just capture all that data in an instant. So now we can get our suction pressure, our discharge pressure, all of our flow rates, and the speed of the pump all in the app all at one time. And now we have a very accurate piece of data of really how well that fire pump is performing.
It's awesome. So it went from handheld pedos where everybody in this room would get a different number to newer technology where if my head is slightly angled different than your head, we're still a PSI or two off.
Yep.
Now to whatever that readout is what it is, right?
Yeah.
Like it just
the
is.
chips fall where they may, right?
Yeah.
And the other direction I think the industry is going from a flow test perspective is supported by our recent acquisition of Global Vision and their flow meter that they make. We've come to learn internationally, and certainly in certain parts of America, that water is a scarce resource. And so I think over time, we're going to see where testing is going to start to move to equipment where we aren't flowing water and that we can recapture water, which is a whole different challenge for the contractors today, because there are contractors in certain parts of the country where they have to reclaim their water due to EPA regulations and things like that. So, I think the movement towards, developing or redesigning a more accurate and dependent flow meter will also start to rule the roost, because 25, 30, maybe 50 years from now, I think codes are going to change to where we don't want to be dumping water out in the environment because it is such a scarce resource.
It's 30 to 50 years.
Yeah, none of us in this room have to worry about that.
That's right.
I know I don't.
Well, I guess the next big question is AI seems to be...
Before you go on,
Okay.
It said compatible to Android. Just wanted to let you know
Nah,
that.
well aware.
Something will be compatible to
Well
your
aware.
Android. Okay, just making
the
sure.
superior technology.
That's it.
But AI seems to be kind of the hot topic for pretty much everybody. And I'm sure it's, as much as we might want to pretend that it's not going to happen to us, it's coming for us. And I think we're starting to see an increase in remote testing technologies. There's a lot more technology being built into pump controllers, into basically every aspect of our lives. Where do you see AI going as far as flow testing goes?
You know what? There's definitely some tools there we can use for AI that's going to help us produce a more efficient test, right? We're working with, we have a great engineering staff based out of the UK. So our parent company is Detector Testers, probably more known globally or in the US here is SDI is their sales branch there, where they make the smoke detector testing pole. Well, they have a huge engineering department. There are about 20 smart engineers that are constantly working on the next innovation. And so they're constantly looking at how can we adapt AI to our next step in technology. So we're looking at a lot of different things of using cameras and visual for AI to recognize it visually of what's going on, so they can help make a more accurate report. There's a lot of new ways that we can be there with AI, and I know that's where we're going, right? We have this in the code that yes, we can do remote testing, but there's still a lot of challenges that we got to overcome to be able to do that remote testing. And ultimately, really, what does it come down to, right? Stuff's going to be leaking when we're done. Packing's going to be leaking. The relief valve's going to be leaking a little bit. And look, even a little bit of water, but that little bit of water can cause a lot of damage over time, right? So that's going to be the next step, right? If we really want to focus in on and be able to do remote testing, we're going to have to figure out, okay, well, how can we get things to not leak though when we're done then, right? And so until we get that, and that's going to be more of a manufacturer standard, right? That the fire pump companies, I think, are going to have to think about maybe how a fire pump works or how a packing gland is going to be adjusted properly. But until we get there, I think remote testing, it's nice. It gives us a goal, right? But I think there's a lot we still have to accomplish before we can get to that point.
Do you have a good test story where things just went sideways without naming any names?
I can think of a few, yeah.
Yeah, I mean, just growing up, right, learning the industry from the ground up, right? I remember one of the first pump tests I went on and, went out and laid out the equipment out the backside of the building. And I being too inexperienced, I didn't really understand geography quite well enough. And I didn't understand that the way the hills were set up, that the water wouldn't roll away from the building, but it would actually roll back towards the building. And so as we're flowing 1,500 gallons a minute, all of a sudden the water starts pouring over the door sill to the pump room, and now we've got water coming into the 480 volt controller area. So again, things that you learn as a young person that you quickly jump over those and make sure you don't do it again.
Sure.
Yeah, I remember for me, one of the first instances I ran into, I was on the job maybe 3-4 months into it, and I was with my boss at the time, and we were going to go out to do a pump test, and found the pump out of service. Jockey pump was off, and so he's like, "Oh well, let's just turn it on and see what happens," right? Not thinking about it, and it fed an underground loop, which wasn't pressurized to system pressure. It was only sitting at city pressure. So he just flicked the fire pump on, and I look outside, and he goes, "I wonder what's happening." I look out, and I see the sidewalk and the grass and everything just kind of floating down the street, floating away. So yeah, I learned awfully quick of how powerful water and water hammer can be right into a system like that. So yeah, there's definitely, you see a lot of things over the years, and hopefully you learn from those, right? And you don't make those mistakes again once you see it the first time. So
my first was a Ford F-350 brand new truck. We were underwriter play piping into a gravel parking lot, and this person driving, I joke that if he was driving a Chevy, he probably wouldn't have. Anyways, Ford comes through and it demolishes the side of his truck. He turns hard, he hits a safety bollard. It's just an absolute mess. And I was thinking back through that to inexperience. I'm like, on our truck across the parking lot was a bunch of safety cones that never came off the truck. Right? Would that fix it? No, but it could have potentially slowed it down.
Yeah. Well, we had a contractor one time that called up that said they made up their own test rig for UL play pipes, right, to be able to measurement. And he's like, oh, instead of putting them on a trailer, I'm just going to put them at the top of my truck, like on my roof rack, and set it up. And he set up his play pipes and set up his fire pump and started. And next thing you know, his car is on the side because all that water tipped his car over, and it was enough of a focal point just to flip it right over. So
the DeLorean with the jets works, but the truck with the underground play pipes.
Well, I remember one of the first pump tests that I went on, and again, this was probably an inexperienced thing, and I didn't know much better, but they had him strapped to the bed of the truck, and things were going okay until I saw the whole truck start to move, and that I was like, that's when it really kind of hit home of how much pressure and power we were dealing with. Was the whole back of the truck was just swaying in the air. That terrified me.
Yeah, absolutely. I mean, that's the reason Hose Monster is here today was firstly water management, looking at that thrust of that water and trying to to manage it better, which was just like Patrick said, the very first Hose Monster was just a diffuser. Still dropped a handheld pitot in it, and then that went on to to the next device and to where we sit today with Smart Monster.
Which one's your favorite device to use?
You know what? Pedalless nozzle, open atmosphere. Nothing better to do a pump test that way, right?
Just make it rain.
Just make it rain. Yeah. Just you don't have to roll out hoses and just
Yeah.
I mean, that's always fun.
And put a smart monster on that and stand inside and take the app.
That's right.
You can't get wet.
Part of me, I think, is just old school. The steel hose monster. I don't know, with the pitot still built in, and
Sure.
I don't know. I enjoy that a bit. What you got? What do you like?
I do like the open atmosphere, just blast. It's kind of like the underwriter play pipes when we were first learning about all of it. It was kind of fun just to launch the water across the field next door, right? But so it kind of gives you that same thing, but probably a little safer, to be honest. But
with his insurance background, I was expecting him to use the manifold or go inside.
That manifold is quite nice. But I mean, they were demonstrating those smart monsters earlier, and I got to say that almost felt like cheating.
Right? It's such a cool piece of technology. It really is. It just makes things. To me, it just opens up the doors. Right? It really just bridges that gap of letting the user know exactly what's going on. They don't have to do a lot of guesswork. They don't have to really even understand it anymore. Right now, they're just looking at their phone and say, "Hey, that's my flow rate."
Right.
And now I know what to do with it. So
I think you mentioned earlier with the accuracy on the digital gauges, and we're not trying to bend over and interpolate a needle that's bouncy, even if it's less bouncy than it would have been, right? There is still some bounce there versus we're getting a very reliable, there's no debate there, but I think we kind of mentioned it earlier when we're looking at the 5%, sometimes it's only a couple PSI. We're making a judgment on whether our pump's passing or failing on a couple PSI, and the gauge is sitting there bouncing a little.
Well, even if it's not bouncing, right?
Or not bouncing, but it's like, okay, we didn't quite read it right, or whatever the case is. Like, the accuracy component is what I think I'm.
Well, even with an analog gauge, right, we're automatically going to default and round it down to the number, right, up or down to the nearest whole number. We're not going to write it down on our form as 10.5, 10.4 by looking at an analog gauge, right? So there's already a little inaccuracy, right? Because that might be 10, 15, 20 gallons with that 0.5%. And you multiply that by 4, 5, 6 lines. Next thing you know, we're a little bit further away analog wise. Digital, though, now we're dead on. So.
Yeah, and besides accuracy, the other thing that Smart Monster brings forward too is and what we've been about too is the fact of time savings, right? You saw how quickly we could dial in the 500 gallons a minute and the 750. I mean, it was a minute or so, right, to do each of those, and that all can be done with one person to accomplish a pump test. We have safety factors that we have to consider in addition to that, but really now with the Smart Monster technology, a pump test can be done essentially with one person.
And the biggest part, I mean, really of any job in fire protection is the labor cost.
Yeah.
Send it to, at first that I shouldn't even think back, but the pump test that I was telling you about, I think we had 2 pumps, 15 hydrants, and I was showing up as a witness at that point. One person in a van shows up with underwriters play pipes. It's like, I don't know how we do this safely with one person, technically speaking there. But the labor cost is always high. Trying to get the job done, one person saves a lot of money.
Yeah. And not only does it save money too, it saves water.
Yeah,
right. If we can flow less water and still do it accurately and still get a good picture of what's going on, that's what we need to do, right? As Michael was saying, we need to be conservative with our water. We need to respect it. So.
Well, and labor costs aside, we're having a recruitment issue for the industry
right,
as a whole anyway. Right. So it might not be a labor cost issue. It might be we just don't have the people.
Yeah, the manpower. Yeah,
right?
Sure.
So if we can help with that, I mean, it's not gonna fix everything, but it'll certainly help.
And younger generation, if it's on an app, I mean,
right,
not hard training.
Plugged in, yep.
Yeah,
it's plugged in already.
If you could get rid of one myth in flow testing or the fire protection industry, what would it be?
One myth.
Accuracy is very important to what we do. We are in this industry for a number of reasons, but one of which is about life safety. Whether you're not a firefighter necessarily, but you are someone, and as a service technician, as a tester, as a designer, it's about saving people's lives, right? And so making sure that pump is going to perform when it's called upon, and that it's the way that's done is through using accurate test procedures and test devices. Will make sure that more and more people live longer lives and it sounds cliche a little bit because, again, praise all the firemen out there who risk their lives on a daily basis running into burning buildings. But, the fire protection contractor, those testing teams hold a great importance in everyone's lives as well.
That's a really good point. That's one. And I think one for me is the pump is probably not the issue. And I really don't like saying it because I love our contractors. When you start to dive into it, whether it's accuracy or the one that I love is you look at the test report and we have a 500 gallon per minute pump. We flowed exactly 500 gallons per minute and exactly 750. And then you start looking at the charts and tables. You're like, there's not really a way. And that skews your numbers, right?
Sure.
Is most of the time it's not the pump's issue. Which
right. Comes down to the user, the gauges, the equipment they're using. And I guess when I think about that too, right, the biggest challenge I see in the industry, the fallacy that's out there is I can make my own equipment. Yeah. I don't know how many times. Oh no, I make my own hose monsters at home. Right,
I'm a good welder.
Right, I'm a good welder. But there's we know look, we study water flow on a constant daily basis. I go home and I think about water flow at night. I think about water flow on the weekends.
It's a lot of trips to the restroom.
Right, exactly. But we know that if we change a measurement, if we made the connection between the pedalless nozzle and the little hose monster a little bit longer, that's going to change the flow rate. So even just a little change here and there is going to adjust your flow rate. So, but really what it comes down to is that what the code says. NFPA says we have to use approved listed equipment, right? So what does that really mean? UL, FM is usually the two most accepted that we talk about. But we go through those settings, right? All of our equipment is FM approved. And we go through that standard. So when companies and they go and make their own equipment or they modify the equipment, they change it, they use it outside of its approval. That's where they start to get into some inaccuracies, but somehow they feel that it's still accurate. And unfortunately, that may catch up with them one day because we're in an industry that has standards, right? And some of those standards come along with insurance companies who can maybe asking questions someday of how you did a test or why you did a test or and what you used and did you use it properly? So,
what's the common ways that people use it outside of the approval? What frequently happens?
One of the things that we have is we have one of our pedalless nozzles has threads on the outside of it. Okay. Now, this was designed specifically to go with our legacy steel hose monsters to replace the built-in pitot tube. You can now use the pedalless nozzle technology, but still use the steel hose monster as a diffuser. It's also there to be used a part of our inline pedalless nozzle kit that we use for standpipe testing. But because it's an NH 2.5 inch NH thread on the discharge side of this, a lot of contractors, they want to attach fire hose directly to it, thinking that, I can just put my fire hose directly on it and now I can get my measurement wherever I need to go. The problem is they're not going to get an accurate measurement doing that because we need airflow. That pedalless nozzle is designed to discharge and it needs that airflow for an accurate measurement. As soon as I put a hose on that, I've now suffocated that and I'm going to have a lot of turbulence and I'm going to create a vacuum in there and just my gauge is going to be all over the place and I'm not going to get accurate readings. So that's where, to be able to do that, to be able to accurately do that, we need 2 points of measurement. We need a Venturi type flow meter to do that. But that's why I see a lot of contractors do. They're attaching fire hose to that discharge side of that pedalless nozzle, and they're just not going to get accurate readings doing that. Or what they might even be doing is they take that pedalless nozzle and they build their own pump trailer. And they say, I'm going to build my own diffusing system. I'm going to attach this to a piece of pipe and have it diffuse this way. And again, they just put a lot of money into a piece of equipment that now they're not going to get accurate readings. So
interesting. I haven't heard that before. But I had another question here. It was all teed up. Messing up here. What's your most challenging and most favorite environment that you've been to go visit or test or facility?
For me, it was NASA.
Nice.
Yeah, I got to go to NASA last year to work with some of their facility engineers on how to use our equipment to do proper fire pump testing. So that was pretty cool. NASA Wallops out in Virginia.
Okay.
So I got to see some cool rockets. There was supposed to be a rocket launch, and I never got to see it when I was there. It got canceled because of weather, but that was a pretty cool, surreal experience to see all the behind the scenes of NASA there and what was going on. It was pretty cool.
It's fantastic. Any UFOs?
I didn't see any UFOs, but yeah.
It's going towards conspiracy.
Not sure you can talk about it.
Yeah, I was growing up in Chicago, being a pump tester in Chicago. What I always thought was really cool was doing a pump test in the city of Chicago because you had to be off the streets by 11 a.m. You started typically at 4 in the morning. But part of doing the pump test in the city of Chicago is that you always had to end the test by doing what is referred to as a roof shot. So you would go up to the top of the building and flow 500 gallons a minute off the standpipe. And so going into downtown Chicago at 5 a.m., the sun hasn't come up yet. You're standing there flowing water, and you can see all the high rises and the lights and stuff like that. It was always as a young person, it was a very cool experience.
Did a roof shot in New York City. It started as a flow onto a roof, and the person we were with started filling up the roof with water. And in typical New York fashion, it ended up as a roof shot at somebody else's roof. And their claim was, well, that's not my roof. It's not my issue.
Not my problem.
Not my problem. So, where do you hope, this digital world, what would you tell a contractor if they're looking, because some contractors are afraid to get into pump testing. What would you tell someone just starting off that wants to get into it?
Get into it. Don't hesitate. But when you get into it, just don't dive in. Get the training, get the equipment, get experienced labor to help you do that. It's a profitable business to be in, but it's a very serious business to be in, and you have to have the right equipment and the right training to make sure you do it.
Yeah, I would agree. It's really just getting out there and making sure you're getting the proper education. Know what you're doing before you go out there and you're getting paid to do it, right? And I think sometimes we see that too often in this industry. We see a lot of technicians go out there and they're doing a job maybe they shouldn't be doing because they really don't have the knowledge base. And sometimes, it's just going out there and seeking out that professional knowledge. We're always here to help. That's part of my job besides just going around to do training classes and trade shows. I spend a lot of time on the phone just talking to contractors all throughout the world and how to do a pump test, how to do a standpipe test, talking them through not just how to use our equipment, but really what does the code say and what does the standard say to really do it accurately. So, knowledge comes with a great power, right? You can make a lot of good money with some good knowledge, but again, it's going to take knowledge, hard work, and the right equipment. So
being on that almost like technical review service, whatever terminology you want, is there a repeating theme that seems to come up that you think would just be good information for the contractors to have, or is it kind of fairly varied in a lot of unique situations?
My experience has been the lack of code knowledge.
Okay.
Part of, we're all been in fire protection, right? And, really phone call rings, whether you were a contractor or you were a manufacturer such as ourselves, is that phone rings and there's really two opportunities that present to yourself, right? One of the opportunity of making a sale, selling equipment, selling services to that particular person. And the other piece to it is education and educating them on, here's the right piece of, if you're a contractor, here's the right piece of equipment to use, and this is why, to the end user ordering services and things, saying, well, here's how we wanted to do those things. And it's kind of, Patrick mentioned it earlier about the telephone game, and I've seen in my time in the industry where the group as a whole has gotten far better in terms of education, but it's still dispelling the rumors of, boy, old Charlie taught me how to do this, and Charlie's been doing it for 25, 30 years, and part of what we do is have to break that telephone call, right?
Just because you've been doing it for 25 years doesn't mean you've necessarily been doing it right for 25 years.
Right, exactly.
Yep.
And when's the last time you looked at the book? That's the other one.
Yeah.
It was right when you were trained, and now it's maybe not, because we've changed.
Yep.
It's not like we change the book often.
No, not at all.
Not at all.
That doesn't keep us busy
Every
at all.
3 to 5 years, that's not that often.
But it's you're staying in tune with what's going on in the industry, and it's getting involved in an organization like the AFSA and get involved in the training programs, whether whatever it may be, and take advantage of those opportunities, because it's a great industry to be in.
Codes and standards process, like 291.
291 that I'm a principal on, 25, and everybody in the industry can participate in the NFPA, right? They're individual organizations. It's a member-driven organization. And because I'm a member and Patrick's a member, we get to vote on those standards and things like that. So we have an effect on the industry.
Are there any last comments or any words you'd like our listeners to hear before we put a bow tie on this one?
I guess to reiterate what I just spoke about, the fire protection industry as a whole is a great industry to be in. getting involved in reputable companies and organizations like the AFSA and the NFPA is the key to success. I think whether you're just want to be an inspector or you're looking at a greater future.
Yeah. Awesome. For me, I think it's just never stop learning. I'm over 50 years old now, and I've been taking classes my entire life. As a firefighter, I would constantly take classes. As a sprinkler contractor, I was constantly going to school. So I think I've been going to school my entire life. But isn't that what we're all here for, right? We're all here to just keep learning about life and become an expert in your trade. But just, never stop learning, because look, this industry is changing rapidly. It's changed so much in the past 15, 20 years compared to how it was the first 120, 130 years. And you got to keep up with that. And the best way you can do that is, stay informed, be involved with organizations like the AFSA, get in contact with your manufacturer's reps. That's your great source of knowledge right there. If you ever have a question about a certain product, how to fix something's not working right. You bought it from whatever distributor, but hey, it's not working. Call directly to that company and find your representative, and they're going to get you the proper knowledge and point you in the right direction to get to what you need to do.
We really appreciate having you both here and having the opportunity to host Hose Monster University, and we look forward to the next time we speak.
Well, we appreciate you having us.
It, guys.
Thank you.
Thank you.
Thanks.
This has been the K Factor Podcast. If you enjoyed the show, don't forget to like, subscribe, and share wherever you tune in to podcasts, or head over to our website for more. Reach out to us anytime at technical@firesprinkler.org. Stay safe and always learn as we keep the fire protection conversation going.